All right, so welcome guys to another session. Today we're going to be looking at networking in DevOps. All right, networking is an essential course. It's something that is very important that we need to understand as a DevOps engineer because we're going to be dealing with systems that need to interact with one another. All right. So in order for us to be able to build such systems, we need to understand the principles, the rules that governs, all right, communication amongst these systems. And that is why today we're going to be looking at networking in DevOps. All right. So let's get into the subject of today. So we're going to be looking at the overview and the concept. All right, we're going to be explaining what networking is and try to help us understand the concept of networking. So let's start with what is computer networking. So computer networking refers to the interconnected computing devices that exchange data and share resources. So which means the reason why we want to have computers connected together in the first instance is so that they can exchange data and they can share resources, right? So that is basically what computer networking seeks to achieve, right? Helping our systems, helping our devices exchange and share resources. Now, how does these computers, how do they do these things? All right, you have two computers and then, all right, they want to communicate within themselves, they want to share resources. How does that happen? Now, this happens because there are a set of rules called communication protocols that have been put in place that allow these devices to transmit information over a physical medium or a wireless medium, which means your devices can either be connected using a cable or it can be through a wireless medium. And for example, even if it's a mobile phone, it can be through a Bluetooth kind of connection, which is still a form of wireless, all right, medium, right? So these computers, these devices, they are able to share resources based on certain rules and communication protocols that define, all right, or that basically administer, the ability for these devices to share resources and to exchange, all right, data. Now that takes us to the next point, which is IP addressing. Now, in order for these devices to share resources, all right, in a network, for example, all right, they need, all right, a form of identity, all right, that allows the device A to be able to identify device B. And that is what you refer to as IP addressing. Now, basically, IP there stands for Internet Protocol, right? Remember, in the earlier slide, we talked about rules, which is referred to as a communication protocol, all right? So one of the protocols that allows for this exchange of data between our devices is what you call an IP address. Now, IP address is a unique address that helps to identify a device on the internet or in a local network, right? Now, in your office, right, wherever it is, maybe you're working somewhere, even if you have a home router, all right, that home router would definitely, all right, give out IP addresses to your systems at home, maybe your mobile devices connecting through Wi-Fi. That home router is responsible for giving that device, all right, IP address, okay, that allows that device to be able to access the internet and all of that. So IP address is basically a unique address, okay, that helps to identify, all right, device on the internet or in a local, all right, network. Now, another point about IP addressing that we need to understand is that an IP address is a string of numbers separated by periods. A string of numbers separated by periods. Okay. Now, what does that mean? I'm sure, some of us have seen an IP address before, right? You know what an IP address is. All right. You know that it's a number. All right. But of course, at every point you find this period. So for example, you have 192.168.1.38, for example. right? Now that is a set of 4 numbers separated by what? By periods. Now each of this number is in the set can range from 0 to 255, which means you can't find an IP address that is 256 dot something. You can't find an IP address that is 296 dot something. You can't find an IP address that is 300, all right, dot something. Okay, so basically the highest number you can see is 255, right? That's the highest number you can see. Okay, so you cannot see an IP address that is maybe 400.200.300. Dot 100, right? The highest you would see is 255. Okay, now let's try to understand these numbers. All right, the question I'm sure you want to ask is, how do we come about these numbers, right? How did we come about, this 255? How did we come about 192? How do we come about, all right, this set of 4 numbers? Okay, now there's an organization that is called Internet Assigned Numbers Authority, IANA, all right, which is a division of the Internet Corporation for Assigned Names and Numbers. Is actually an organization that was started in the US in the year 1996 or 1998 thereabout. All right, now they are responsible for allocating, all right, IP addresses. Now IP addresses are not random. We need to understand that, because I'm sure some of you may be wondering, all right, how did we arrive at 192? How do we arrive at the fact that, all right, IP addresses, the range cannot be more than 255? How did we get to that point? Right? Now, these numbers are mathematically produced. All right, so they follow a mathematical formula. In fact, a very simple formula, which is basically just a binary and a decimal kind of conversion. All right, and then we're going to get into that in the next slide. But one thing we need to understand is that IP addresses are not random. All right, they are numbers that are mathematically computed based on what our system understands, based on what computer, all right, can work with. Okay, so let's take a look at the classes, and then from there we'll be able to understand how we arrived at these numbers, how we come about the 192, the 255, and all of these things. But before we go into that, let's understand, all right, IP address classes. Now, we have established that IP addresses, all right, is a unique number assigned to our devices, which helps us to recognize or identify them on the internet or in a local area network. All right, we've established that fact. Now, one of the things that we need to also understand is that these IP addresses are in categories, or something you can call classes, right? That is actually the right word for it. All right, classes of IP addresses. Now, there are 3 primary classes that we're going to be looking at. All right, we have class A, we have class B, and we have class C. Now, the question you may have on your mind is, what really is the difference between these classes? All right, why do we have classes of address? Okay, can't we just have, one address and then everybody can use that? No. All right, the IP address, basically the IP address we're talking about here is IP version 4, Internet Protocol version 4. All right, so there are 3 primary classes. Of course, we have other classes. We have class D, we have class E. But for the purpose of what we're discussing today, all right, there's no need to go into all of those classes, right? So let's stick with the 3 classes that we have. So class A, class B, and class C. Remember, we have said that IP addresses, all right, is a set of 4 numbers separated by periods, right? That means it starts from 0 up to 255. Right now, the IANA, in their wisdom, all right, divided these numbers into different classes, and then we have what you call a range of address. Now, for the class A, the address ranges, all right, from 0 to 127. Right, 0 to 127. Now, I'm sure you're familiar with the 8.8.8.8, all right, DNS address of Google, which is a popular, all right, DNS address, all right, and then we have the 4.4.2.2. Now, these are public addresses, all right, that you can use, all right, as your DNS address. Okay, now, all of these addresses that I mentioned, the 8.8.8, the 4.4.2.2, all right, fall within the class A address, because as you can see from here, I have 0 to 127. right? So which means tomorrow, if I see an IP address that starts from 13, for example, I know definitely, oh, that's a class A address. If I see an IP address tomorrow that starts from, let's say, 50, for example, all right, I know that that is a class A address based on the range that has been defined by the IANA, right? Now, for the class B address, that simply just took off from where class A stopped. So for the class B address, you have address ranges from 128 to 191. That tells you that if you see an IP address that is 132 dot something, for example, you instantly know that, oh, that is a class B address. If you see an IP address that starts with 121, or no, 130, for example, or you see an IP address that starts from maybe 140, for example, you see an IP address that starts from 150, for example, you know that that is a class B, all right, IP address. All right, now let's move on to class C. Now, class C also is basically just starting off from where class B stopped. So class B stopped from at 191. So that means if I say an IP address that is 191, that's something, I know that that is still a class B address. But then if I see an IP address that starts from 192, definitely I know that that is what? A class C IP addresses. Now, one thing we need to clarify very quickly is that now when we talk about IP addresses, we have what you call private addresses and we have what you call public addresses. Now, the INA that we mentioned earlier in their wisdom, they decided that, okay, now if we have all of these addresses, now there are some people who need to connect their devices, wouldn't necessarily don't have to maybe expose these devices to the internet. Maybe a small office, for example, they have 10 systems and then they want to connect these 10 systems together, or just basically to share files and office amongst, colleagues and staff members and things like that. Now, these systems don't have to be on the internet. So how can you connect such systems? All right. So what provision can we make to accommodate, all right, such kind of, connection? So they came up with the idea that, okay, from this pool of IPv4 addresses that we have broken down into different ranges, why can't we block out certain ranges from these addresses and then designate them, all right, just for local area connection purposes? Which means if there's an office, they have systems they want to connect together, they don't necessarily need to approach an ISP, which is an internet service provider, for an IP address. They can just speak from these reserved IP addresses, all right, and then allocate that to their systems within the organization, and then these systems can, of course, share resources between themselves. So they came up with that knowledge, and so that is why you have public addresses and you have private addresses, right? For example, if you see an IP address that starts with 10, okay, any address at all, if it starts with 10, you know that that belongs to class A, and in addition to that, that is also a private IP address. All right. So tomorrow, if you see an IP address that is 10.1.10. whatever, you know that two things, all right, two things are clear, that this address is a class A address, and number two, that this address is what? It's a private IP address. Now, what again is the difference between a private and a public address? Now, another thing that you can use to distinguish them is that public addresses that are reachable, all right, from the internet, right? Which means if I have a public IP address, for example, right, I can ping a public IP address from anywhere. Right? I can access a public IP address from anywhere. Now, a private address is meant to just be used locally, which means private addresses are not addresses that are routable. They are not available on the you cannot reach them from the internet. Right? If you're not in that building, if you're not in that office, you can't do anything, all right, from the outside, okay, with a private IP address. So that is the difference. So one is accessible from the internet. The other one is basically just used within an organization. All right. So that is another difference between a public and a private IP address. Okay. Now moving on, class B addresses, all right, the reserved addresses for class B start from 172.16 up to 172.31. Which means if you go on AWS, for example, if you have observed carefully, right, if you have had anything to do with AWS, particularly the VPC section, you would realize that the default VPC that you have created for you by default in all the regions of AWS, all right, start with 172.31. Now, that is a private address. It's an address that you cannot use, all right, on the internet. Nobody can access your devices using that IP address because it is basically a private address. Okay? Now, for Class C as well, IANA in their wisdom decided to reserve, all right, certain portion of the Class C address. And so anywhere you see 192.168, you know that that definitely is a private IP address. All right. That is the private IP address. But of course, that address belongs to what? Class C, all right, address. Okay. I hope that explanation is clear. So let's move on a bit. Now, in addition to reserving, certain ranges, all right, for, local area consumption, all right, just internal kind of connection. Now, there are reserved addresses within each of these, all right, classes. Now, for example, do you have this popular 0000? Now, what does this mean? Because, you're going to be seeing this a lot, all right, by the time we get to the AWS module, when we're going to be talking about VPCs and all of that, and route tables and things like that, all right, we're going to be dealing a lot with 0.0.0. But just to give us an idea of what it means. Now, 0.0.0 is basically an IPv4 address that is basically used to refer to a default network. All right, that's what it means. So, for example, if I have systems connected locally, now if this system needs to access the internet, right, they have to get something from for example, they want to access Gmail, for example. Now, Gmail is not hosted within, all right, our organization, right? That means it has to go outside of my local area network to the internet, all right, in order for me to be able to access Gmail, right? Now, of course, within that your local area network, you will have what you call a router. Now, the router is also referred to as a gateway, all right, that can connect your local systems, all right, to the outside world. Okay, and this default route is one of those things that you're going to configure on your router, which basically means if there is any resource that you're looking for that is not within the local area network, then send it to this default network, and then the gateway knows how to figure that out, basically. All right, so that is 0.0.0. We're going to talk more about that when we get to the AWS VPC section. Now, another address that is very popular, I'm sure most of us have seen this before, or even if you've not seen it before, I'm sure perhaps you've heard of, local host or something. Now, it is 127.0.0.1. Now, this address is referred to as what? A loopback address. Now, every system in the world has a loopback address, right? Which is 127.0.0.0.1. Now, if you don't believe me, you can go on your system right now and then open your command prompt and do ping 127.0.0.1, and then you'll be shocked that you're going to get a response back from your system. Now, this address, it's one of the ways you can actually use to test your local area network interface, all right, just to see that maybe it's alive or something. All right, and in most cases, referred to as what? As a local host, just basically testing your own, all right, LAN connection or your LAN port, for example. Okay. Now, another address in that category is the 169.254, all right, to the 169.254.254 range, which is basically an address that is automatically assigned to a LAN interface or a wireless interface if that interface is not able to successfully receive, all right, a valid DHCP address. All right, it's not able to receive what? A valid, all right, address, maybe from the router or from the gateway it is connected to. So it just generates a default, all right, range of addresses. Now, these addresses are used for different reasons. All right, for example, when you want to query your EC2 user data or things like that, you can also use this address. All right, we're going to do more on that, all right, when we get to the EC2 section on AWS. Now, the last reserved address on our list here is the 255.255.255.255. Now, I know that we have not gotten to the mathematics, all right, behind these 255.255 address, but just, hang on there. We're going to get into that, very shortly. All right. Now, this address is referred to as what? A broadcast address, which means if one computer or one device on the network wants to send out a message to other devices, it sends out what you call a broadcast, which means everybody receives that message. All right. And the address that is used for this purpose is referred to what? 255.255.255.255. Is that okay? Now, let's get into, all right, the mathematics behind these numbers. All right. And that is what we are referred to as the decimal binary formula. All right. Understanding the power of 2. Okay. Now, in the elementary mathematics, you have, of course, when you do binary, to decimal conversion, you have what you call the 2 raised to power. All right. There's 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 4, 5, 6, 7, and all of that. Right. Now, this simple decimal binary formula is what was used to come about, all right, the IP addresses that we have. And that is why we're able to arrive at the fact that, all right, a set, all right, cannot be more, all right, than 255. So let's get into these and let's see what happens. Again, let's have this table, all right, here. We've already talked about what this table signifies, but then again, we need to, all right, have these as well, because remember, we said each number in the set can range from 0 to 255, all right? So let's get into, all right, what this is. Now, IPv4 format is 4 bytes long. Right? So which means each set in that IP address is what? Is 1 byte. Now, a 1 byte is equal to what? Is equal to 8 bits. All right, is equal to what? Is equal to 8 bits. So if you look at an IP address, for example, the 192.168.1.38 that we have here is just basically a 4 byte address, right? With each of the set being 1 byte, and a single byte is what? Is 8 bits. So if you look at this IP address, if you look at it here, it's basically just 32 bits of address, right? 4 byte, and then that equals to what? 32 bits of address. All right. So let's get into the calculation here. Now, going back to our, binary, decimal binary formula. All right. Now, if you look at the powers of 2, now, anything times 0, we know that is 0, right? But anything raised to the power of 0 is what? Is 1, right? And then 2 raised to the power of 1 is what? Is 2. 2 raised to the power of 2 is what? Is 4, and then on and on like that. Now, remember, we have said that 1 byte is what? Is 8 bits. So if you look at the numbers we have here from the 2 to the power of 0 to the 2 to the power of 7, we have what? We have 8 numbers signifying one set of the IP addresses. So which means each of the set is referred to as what? 8 bit. So you have 8 bit, 8 bit, 8 bit in 4 places. Okay, and then if you do the math, you discover that you have 1, 2, 4, 8, 16, 32, 64, up to 128. Now, if you add all of these numbers together, all right, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, if you add all of these numbers together, what are you going to get? Of course, the answer is 255. Right? Now, that is how we arrived at the number 255. Basically adding all the numbers together. All right, 128 plus 64 plus 32 plus 16 plus 8, all right, plus 4 plus 2 plus 1, that will give us 255. Right? So you've seen how we arrived at the number. Now let's do a little bit of conversion here, all right, to understand the binary side of things, because this is the decimal, side of things, kind of. All right, now this address that we have here, 192.168.1.38. Now, if we were to convert this to binary, what do you think it will give to us? All right, I'm sure your guess is as good as mine. So let's look at this. So 192.168.1.38, what is going to be the binary equivalent of this number? Right? Now look at that. So the binary equivalent is going to be what? 11000000. Now, how did you know that it's 1, Of course, 192, all right, how are we going to get 192? 192 basically is an addition of 128 plus 64. Right? So 120 plus 64 is going to give us what? 192. And then the rest is what? Is 0. So that's how we got the 192. So how are we going to get 168? So what combination will give us 168? Take a look at that. So we have 1, 0, 1, 0, 1, 0, 0, 0. So basically, that is the addition of 128, all right, now plus 32, because if you had 128 plus 64 together, that is obviously over 168, right? So that is 128 plus 32. All right. Of course, if you add 16 to that, that would be more than 168. So we have plus 8, and then that gives us 168. And of course, you know, the third octet, right? The third set there is 1. So that is basically just the last number, right? Every other thing is 0. And of course, the last number we have here is what? Is 38. So what's going to give us 38? So that will be 32, all right, plus, all right, your guess is as good as mine, right? So 32 plus what? Plus 4 plus 2, that will give us 38, right? So now you understand where we got the 255 from. So when you see an IP address 192.168, you can, by now, you should be able to know, oh, okay, so I think I know the binary equivalent of this. So if you see an IP address that started with maybe 200 or something, right, you could easily, all right, convert that to binary and understand how they got that number, all right, in the first instance. All right. So this is basically to show us, all right, how these numbers were arrived at, so that we don't just think they are just random numbers that anybody can just, you know, form and then just use, right? There is a formula to it, and then the formula is just basically a decimal, all right, to binary, and understanding the power of twos. Okay. All right, so let's get into something interesting, and that is the subnet mask and what you call the CIDR. Now, what is a subnet mask? Now, let's take a look at this table, for example. Now, in the earlier slide, we've talked about the classes of address, right? We talked about class A, class B, and class C, okay? Now, each of these classes, they have what you call a default subnet mask. Now, what basically is a subnet mask? What is a subnet mask? Now, a subnet mask is basically a way to identify, all right, two things basically, all right, the network portion of your address and, of course, the host portion of your address. Now, what do I mean by the network portion and the host portion of the address? What does that even mean? Okay, so let's take a look at this. Now, the class A has a default subnet mask of 255.0.0.0. And I'm sure some of us have seen this CIDR before, which is /8, right? Remember, we said that each set in the IP address is what? Is 8-bit, which is basically 1 byte equals to 8 bits. Right now, for class A address, all right, the default subnet mask is 255. Now, 255 means that all of the bits are basically turned on, right? You know, in the earlier slide, when we calculated all of that numbers, it gave us what? It gave us 255. So, which means if all the bits, all right, in the first set is turned on, what are we going to get? We're going to get 8 bits, right? So that is where we got what? /8. Right now, this /8 is referred to as a CIDR notation, all right, or you can call it a subnet mask. So 255.255.0 is what is called a subnet mask. The /8 there is basically what you refer to as what? A CIDR, all right, notation. Is that all right? Okay. Now, a subnet mask is a 32-bit number, which means when you add every of the set together, right? Set 1, which is 8-bit, set 2, another 8-bit, set 3, another 8-bit, set 4, another 8-bit. Now, by the time you add all of these 8-bit together in 4 places, it gives you what? It gives you 32-bit number. Remember, we have said an IP address is what? Is 4 bytes. Okay, and each byte is what? Is 8 bits. So if you do 8 times 4, what you get is what? Is 32, right? Okay. Now, one thing about a subnet mask you must understand clearly is that it is basically just a method that can help us to understand how many host address do we have, all right, in this address, and how many networks can we get, all right, from this address. Basically, if I want to divide a network, for example, maybe somebody give me, all right, an IP block, for example, right? Now, the CIDR notation or the subnet mask is what will allow me to know, okay, the number of hosts that I can get from this block of address. Okay, so basically what we are saying is that the subnet mask is basically helps us to separate the IP address into what? Into the network portion and the host addresses. So for the class B, for example, the default subnet mask is what? Is 255.255.0.0, which will give us /16, just basically adding two of the sets together, 8 plus 8 to get 16. For the class C address, all right, the default subnet mask is 255.255.255.0. All right, when you add all the three sets together, it gives you 24. So the default mask is 24. So tomorrow, when you see an IP address that is 192.168, all right, 5.0/24, you definitely know, oh, that is a class C, all right, address. So let's take it a step forward. Now, going back to our table here, all right, we already know that if we add all of these things together, it gives us 255, right? So let's take a look at class A in binary. All right, so in binary, this is going to be class A, 1.1. So all the first up bits, all right, the first set, everything is turned on, all right, and then the remaining ones we have 0, and of course that will give us the default subnet mask. And then the same thing happens to class B, all right, you have the first two, all right, set turned on, which is once, all right, and then you have that, and then you have the default subnet mask. And then for the class C, all right, you have the same thing as well. So all the first three, all right, set is turned on, and then the last one, all right, you have zeros, and then that gives you this default. Now, one thing I need to point out here is that now all the ones, for example, for the class A address, the one bit that we have on in the first set, you cannot modify that because that is the default. All right. That is the default. So which means you cannot have a class A address that has anything that is below the /8 CIDR notation, right? You can't have /7, for example. You can't have /6, for example. No. It has to be between /8 and /15. Is that all right? Okay, now for the class B address, you have two sets turned all on, which is 1111. All right, you have 255.255. Now that two sets, right, cannot be modified. All right, okay, because that is the default. So which means you cannot have a class B, all right, address with a CIDR notation of what? Of /14, for example. Right? So which means if I see a CIDR notation with /14, I know that definitely that is a class A range, all right, address. But if I see something that is between 16 and 23, I know that definitely that is what? A class B, all right, range of address. Okay, so the same thing also happens to class C. So the first three set, all right, we have them all turned on. That will give us /24, which means I can't modify the first three set. If I need more networks, right, what do I modify? I basically modify the zeros, all right. I basically turn them on to produce more network. That means I can't find a /C address, all right, that is below /24. So which means if I see /23, that tells me that this is a class B address range. So anything that is between 24 and 32 or 31, for example, all right, I know that, oh, that is within the class C address range. Is that okay? All right, so let's take, all right, a few examples as we wrap up, all right, this subject. Now, what is subnetting? We've already talked about subnet mask, and we said subnet mask is basically, all right, a way to understand, all right, the number of addresses that we have. Basically, it helps us to identify the network portion of our address and the host portion, all right, of our address. So let's see, all right, what subnet mask basically is in 3 steps. Now, you can do subnetting, all right, using 2 requirements, right? It can be based on the network requirement. It can also be based on the host requirement. For example, somebody gives you a block of address and then tells you, oh, from this address, I want you to generate for me, all right, 3 networks. Right? So for example, you have 3 different accounts. So I want one subnet for account A. I want another subnet for account B. I want another subnet for account C, right? From a single block of address. So how do you generate, all right, the networks? How do you generate even the number of hosts in that? So we're going to start with subnetting based on network requirement. So the example here, or the steps we have to follow, are just 3 simple steps. Right? So when you want to subnet an address, there are 3 simple steps. The first one is that, number 1, you have to convert the number of networks to binary. That's the first thing. Number two, you have to reserve bits in the mask and find your increment. Number three is you have to use that increment that you have discovered to generate the network ranges. Now, what does this mean? Okay, now let's take this example. So you have been given this block of address, all right, 192.168.5.0/24. Of course, from saying /24, we know that, oh, this is a class C address, right? So you have been given this, and then you have been asked to generate, all right, let's say 5 networks from this single block of address. How do you do that? Now, following these 3 steps that we've highlighted above, how do we do that? All right. Now, the first thing is that we have been told we need 5 networks, right? So how do I get 5 networks? Now, here I said 5 networks equals 3 bits. What do I mean? Now, if I do 2 raised to the power of 0, all right, that gives me just 1. But I need 5 networks, right? If I do 2 to the power of 1, that gives me just 2 networks, okay? But I need 5 networks. So if I do 2 to the power of 2, that gives me how many? 4 networks, right? But what I need is 5, right? So if I do 2 to the power of 3, that gives me what? That gives me 8. Now, that sounds like what can fit into the requirement that I have. So I need 5, but 2 to the power of 3 would give me what? Would give me 8. So that is like the closest, all right, to the number that I have. Because 2 to the power of 4 will give me 4, which is below the requirement, all right? So the next is 2 to the power of 3, which will give me 8. Now, that is far, all right, it's beyond the requirement, but of course, it's still within what I've been asked to do. Right? So that would basically mean that, all right, I need 3 bits, okay, to get 5 networks. 3 bits. So follow me here. Now, the second thing or the second step says reserve bit in the mask and find your increment. Right? So I already know that I need 3 bits. Now, you don't have to worry whether it's to the right or to the left. What is important is that how many bits do you need, all right, to get the number of networks that you need. That is what is important. Okay? So I need 3 bits. Now, the second one says I should reserve bits in the mask and find my increment. Right? Now, if you look at the second line here, all right, I know that this is a class C address. So that would tell me that, all right, the first 3 sets, all right, will be 1, 1, 1, 1, right? Now, the last set, which is the 4th set now, all right, is all zeros. But of course, I need to reserve 3 bits, okay, from that in order to be able to have my 5 networks. So I have 1, 1, 1. So from the zeros, from the 8 zeros, I have to do what? I have to reserve 3 bits from the 8 zeros, okay, in order for me to get the 5 networks that I need, okay? Now take a look at this. Now the last step that says, it says use that increment to generate, all right, your network ranges. Now I have reserved 3 bits, which will give me, all right, my 5 networks that I need, right? Now, in order for me to be able to generate my 5 networks, the third step says we should use the increment, all right, to find, all right, our network ranges. Now, what is my increment? How do I get the increment? Okay. Now, the 3 bit. Now, the last bit of that 3 bit is what I'm going to use as my what? As my increment. Okay. Now, it's just a simple formula. Okay. The last bit there. So I have 3 bits. So 1, 2, 3. All right. So even if it's 4 bits, all right, even if it's 4 bit, all right, the 4th one will be my what? Will be my increment. So the last bit is always what? Is always your increment. All right. So the last bit is always what? Is always our what? Our increment. Is that okay? Now, if the last bit is our increment, so how do we do, all right, this calculation? How do we go about this calculation? Now, if I know that the last bit is my increment, all right, how do I go from here? Right? Now that means that the last bit is basically 2 to the power of 5. All right? Because if I'm going by, all right, my binary to decimal calculation, if I look at it here, 3 bits have been turned on. So I have 128, I have 64. The last bit is basically 2 raised to the power of 5, which is what? Which is 32. So that means 32 is my what? Is my increment. Is that all right? Now, if you look at what you have here also, the subnet mask has also changed, right? Now, the default subnet mask for /24, as we already know, is 255.255.255.0. But now we are breaking, all right, a single network, all right, into 5 different networks. So it cannot be, all right, the default subnet mask again. The subnet mask has to change. Okay, so now we have what? We have 255.255.255 dot what? Dot 224. So how did you get the 224? It's just basically adding the 3 bits together. So 128 plus 64 plus 32 will give you what? Will give you 224. And that is your new subnet mask. Now, if you look at the last thing here, it is 192.168.5.0/27. So how did we arrive at the 27 again? Remember, we have said a 3 set is equal to what is 24. 8 plus 8 plus 8, that will give us 24. All right. Now, if you have the 3 bit that we've turned onto it, that is what? 25, 26, 27. All right. So our new CIDR will what? Will be /27. Is that all right? So that is how we arrived at, all right, the 5 networks. So now how do I now generate, all right, my network ranges, all right, and my host address? Pretty simple. That means my network address will be what? Will be 192.168.5.0. All right, my host address, which is the first usable IP address. Remember, in most cases, the 192.168.5.0 is a network address that you cannot assign to a system. You can't assign that to a device. It's basically just an address that helps to identify the network. All right, so the host address is now what? 192.168.5.1. All right, so that is the first usable host. Now, if my increment is 32, you must have guessed right, which means the host address will range from what? From 1 to 30, which means the first address, all right, and the last address within that network, all right, will be reserved. So the first address is what? The network. The last address in that network is what? The broadcast for that network. All right, so the address you have between the network and the broadcast is what you refer to as what? As your host address. So if my increment is 32, it means that my usable IP address from this network will be what? Will be from 1 to 30, which means I can assign, all right, 5.1 to a system up to 5.30, right? Remember, we need 5 networks, right? So let's take a look at the second one. So the second network address will be what? 32. Okay, dot 32. That'll be the network address for the next, all right, for the next range, basically. All right. So 192.165.32 will be the next one. And then the host address for the next one will be what? Will start from 5.33, all right, up to that. So basically, you just add 32. So for the next one, we had another 32, which will give us 64. And then we have all of that address there. The next one will be 96, all right, and then we have all that until you've gotten your 5 addresses. So what can happen now is that you can take each of these address and then assign them to the different accounts. Remember, these addresses are derived from where? From the initial block of address, which is 192.168.5.0/24. All right, so they are still, all right, part of that block. But what we have simply done is to what? Subdivide, all right, that block into, all right, multiple networks. All right, so the first one can now be assigned to account A, the second one can be assigned to account B, the third one can be assigned to account C, and then if we have other accounts come up tomorrow, all we need to do is to what? Is to assign that, all right, to, okay, to the other account, all right, when we have them, all right, come up later on. Now, this is basically subnetting based on the network requirement. Now, if you want to subnet based on the number of hosts, right, that is also very simple. For example, if somebody comes to you now and says, oh, I need, let's say 14 IP addresses. I have 14 devices and I want to assign IP address to all of these 14 devices, right? How do I go about that? It's just the same simple step, right? The same simple step. So now you have to convert the number of hosts to binary, all right, reserve bits in the mask and find your increment, and use the same increment to generate your network ranges, and basically you follow the same pattern. So let's quickly do this. So we have the same address, 192.168.5.0/24, and somebody has told us I need 14 hosts, right? I want to connect 14 devices. Now 14 hosts basically would give us 4 bits. Right? Like the example I gave earlier, 2 to the power of 3 will give us 8, but 2 to the power of 4 will give us 16, which is within, all right, the number of addresses that we need for our host, right? So 2 to the power of 4 is what we need. So that is 4 bits. Okay, so that means you have to turn on, all right, 4 bits. So like you can see here, 4 bits have been turned on, all right, and then that last bit is going to be what? It's going to be our increment in this instance, right? And that last bit is going to be what? 16. So that means my address or my network will increase by what? By 16. Is that okay? And if you look at this very closely, the subnet mask has also changed. All right. So the new subnet mask now is what? 255.255.240. Basically just adding those numbers, right? The three, all right, the three set will give us 24. And then we have turned on 4, all right, from the host address. So, all right, so we have 25, 26, 27, 28. Now that will be the side annotation, right? But for the subnet mask, that will be 240. Because if the three, all right, if this three will give us, if you look at it very closely, if you had all the numbers together, 128 plus 64 plus 32 plus 16, that will give you what? That will give you 240. So the new subnet mask is going to be 240, and the new side annotation will be what? Will be /28. All right. And so the same thing that we saw earlier. So if I want to do my addressing now, I can see that my host address will still start from .1, but then the broadcast address will end at what? At .15. All right. And then the next one will be 16. So my host address now is going to be between 1 and what? And 14. So that gives me my 14 hosts, all right, per network, which is within my requirement. All right. So I hope this is clear enough for you. All right. All right. So thank you so much, guys, for sticking to the end of today's video. We hope you were able to gain some insight, all right, into what we discussed in the video today. All right. We hope to see you in the next video, and we want to appeal to you once again. If you're yet to subscribe, please hit the subscribe button. Like this video, share it to as many people that you know that would benefit from, all right, these sessions. Okay, so thank you so much, all right, and we hope to see you in the next video. Bye for now.